Welcome to the first lesson under the topic chemical bonding. We will be looking at the first type of chemical bonding, which is ionic bonding. The learning points will be we should be able to state which type of element ionic bonds can exist between. We should be able to describe what happens to electron when an ionic bond is formed. And we should be able to explain some key properties of ionic compounds. Alright, let's get started. Elements. Ionic bond formed between metals and non-metals. So ionic bond exists between both metals and non-metals. In the periodic table in our previous bundle, metals can be found in the middle and on the left hand side of the periodic table, while these are metals, while non-metals can be found on the right hand side of the periodic table. Now, what are ionic bonds? An ionic bond is formed when a metal and non-metal react. It formed as a result of reaction between metals and non-metals when metals combine to form a chemical compound with a non-metal. The metal atoms become positively charged ion by losing electron, and non-metal atom become negatively charged ion by gaining electron. So there's loss of electron, there's gaining of electron. The metals lose electron to the non-metals while the non-metal gain electron. The metals lose electron in order to become ionized and become positively charged, while the non-metal gain electron to become negatively charged ion. So the oppositely charged ion are very strongly attracted to each other. Like we know that opposite charge attract, so they are strongly attracted to each other. So the force between them, or the kind of attraction between them, is known as electrostatic attraction. Now let's see forming of positive ion and forming of negative ion. Metal atoms lose electron to form positively charged ion with a full outer shell of electron, and non-metal atom gain electron to form negatively charged ion with a full outer shell of electron. Here we have lithium. The lithium will lose this valence electron and has a full outer electron shell that obey the duplet law of stability. And here we have fluorine gaining one electron to also become negatively charged and become more stable with a full outer electron shell. Let's look at typical example. This is magnesium, the reaction between magnesium and oxygen to form magnesium oxide. So for elements in group 1, 2 and 3, the number of electrons lost is the same as the group. For example, magnesium is in group 2, it will lose 2 electrons. Sodium is in group 1, it will lose 1 electron. Potassium is in group 1, it will lose 1 electron. Aluminium is in group 3, it will lose 3 electrons. And also for elements, the non-metal in group 6, 7, the number of electrons gained is 8. Subtract the group number. What we mean now is that for example, for group 6 element, when you subtract the electron gain, when you want to get the number of electron gain, just subtract their group from 8. For example, oxygen in group 6 element, subtract 6 from 8, it will give you 2, which means oxygen gain 2 electrons. Chlorine, for example, group 7, subtract 7 from 8, you have 1, which means chlorine gain 1 electron to form ion. Let's look at a typical compound that exhibits ionic bonding. Sodium chloride, table salt. Chlorine gain an electron from sodium to become a negative ion. Sodium loses an electron to become a positive ion. So both ions now have a full outer shell of electron, and the ionic compound sodium chloride is formed. So we can see chlorine with one extra electron in the outer shell, that's the valence electron, and we can see sodium rather, and we can see chlorine with one less electron at the outermost shell. So when they go into combination, sodium transfer this single electron, and you can see the single electron here at the outermost shell of chlorine. Another example is lithium oxide. You have two atoms of lithium. This release one electron. One atoms of lithium release one electron. The other one releases one electron. And oxygen gain both electron in order to have a full outermost shell. So each lithium atom loses an electron to become positively charged ion, and the oxygen gain two electrons to become a negatively charged ion. Now let's look at the properties of ionic compound. We will look at the property under these three headings: the ionic lattice, their conductivity, and the boiling and melting point. Now an ionic compound is a regular repeating structure of ions known as giant ionic lattice. So ionic compound form a giant ionic lattice, and the lattice is composed of a repeating pattern of oppositely charged ion held together by strong electrostatic force. We can see regular pattern: positive, negative, positive, negative, positive, negative, positive, negative, positive. The same thing when you check it downward. It follow a regular pattern of oppositely charged ion. Another property is conduction. Ionic compound conduct electricity when they are melted or dissolved in water to form aqueous solution. In this state, the ions are free to move from one place to another. So ionic compound cannot conduct electricity when is in solid state, because their ion will be in a fixed position. But when they are melted or dissolved in water to form aqueous solution, they can conduct electricity. While in solid state, they can't conduct electricity, and the reason is that the ions are in fixed position. They are not moving freely. Other properties of ionic compound is the melting and boiling point. Ionic compound consists of oppositely charged ion held together by strong electrostatic force. We've stated that. That's the force of attraction between the oppositely charged ion. So a lot of energy is required to overcome this strong attraction. So hence, this gives rise to their high melting and boiling point, because of the high energy required to overcome the electrostatic force of attraction between their molecules. Right, let's look at some practice question before we go into the summary. Which type of bonding always take place between metal and non-metal? You know the answer: ionic bonding. The chemical sodium chloride involves which type of bonding? It is cited in the example. The answer is ionic bonding. So a quick look at the summary. Ionic bonding involves transfer and receiving of electron. Metallic element transfer the electron, while the non-metallic element receive the electron. Join me as we go into the second lesson. Thank you.